The metaverse is a reincarnation of earlier technologies, but with an added aspiration of scale. Its aim is to be omnipresent, always there, always ready, the merger of a digital twin of all things real with all 3D born digital, granting access to what happens, what we capture, that we share. There's not just one metaverse. Its manifestations are manifold and multifarious. Okay, sure. There's not just one metaverse. Its manifestations are manifold and multifarious, ranging between simulation and augmentation on an extended reality continuum, and from intimate to co-experienced in its social scope. Its genesis of 3D and 4D, 3D over time, has two modes: by observation or by formation. Cameras and increasingly other sensors like laser pulse detectors are used to generate imaging inputs for 3D reconstruction, keeping track of properties and characteristics of real-world objects. Alternatively, computer-aided design and its modern derivatives are deployed to visualize what the human mind wants. Maybe these are not distinct modes, but rather two sides of the same coin, yin and yang, opposites but interconnected. There, however, is a rift between configuration time and real-time approaches, often restricting live updates to low fidelity, but requiring computationally expensive methods for high-fidelity content. Not only me, but others have recognized that significant challenges stand in the way of the metaverse becoming a success. And not, in the words of Tlili and colleagues, 2022, a metaverse. According to Tlili et alia, these are three. Deliver innovative technology for quickly populating the metaverse, establish seamless coexistence of digital and physical environments, and last but not least, motivate and educate digital literates capable of operating these new technologies. Regarding the first one, generative AI is starting to make history. And all three approaches of model-based parametric geometry, text to 3D, and one-shot reconstruction are becoming feasible and aesthetically pleasant. I've picked examples from industrial systems to illustrate this and to underline how close to market research here rides. The first one is Sloyd, priding itself on instant automatic 3D creation. Sloyd provides category-based access to model configurators. Here an example of an oven and its configuration options. Changing the wackiness of the oven may not matter so much if you're redesigning your kitchen, but it matters a lot when you're designing a game, creating fitting, aligned optics across all game artifacts. The second one is from 3Dify, a text to 3D generator with growing inventory. Picking the example of a sofa, or more precisely, a gentleman's Chesterfield sofa with 2 seats and a wraparound back and wooden feet, you can see, slightly abbreviated in the video, that in mere 5 minutes, you receive a fully fledging textured 3D object ready for export. But it doesn't stop there. Ready Player Me provides a one-shot 3D avatar generator, same as several others, producing avatars rigged, ready for animation. So we can inject our model into a motion capture database like Adobe Mixamo, enabling the avatar to do what I mostly never could do in real life. Avatar ready, download. Secretly, I cut something from this video that is conversion. If you want to know how to do that, ask me later. And upload, and here we go. This is, by the way, how I enjoy breakdancing the most. Yeah. Quite an amazing breakdancer, am I not? Yeah, to break maybe with my vanity, let's pick something else and look at a second not so pleasant example, and here we go. Patient dead. But how can we deal with the second challenge? How can we deal with the second challenge of synchronizing harmonically between the physical and the digital? As initially mentioned, we can do this by reducing fidelity. Here is an example from my own work, or the work of my group, I should say, standing on the shoulders of giants, with Mirage XR, the open source project for learning with extended reality. Mirage XR has a so-called ghost track augmentation, which records indoor body movement with a lower frame rate and the voice of an instructor or a student. Here, it was an astronaut trainer in a Mars surface simulator at a project partner site in Italy. The ghost is recorded with a live preview, but what we see now is its replay, the replay of a so-called ghost track, a powerful and engaging tool enabling a virtual instructor to be present even when he is no longer there. This brings me to the third challenge, enabling users to operate these technologies. I'm certain that AI has a prominent role to play as the new user interface of the metaverse. Embodied assistants could well be the next dominant technical design. We call them holographic AIs. They provide an embodied user interface, a virtual human, projected into the real world to interact with the user and to respond to events and characteristics in both the physical and the digital surrounding. That may sound a bit abstract, so this is what they could feel like.
Hello. Hi, I'm Hannah. Where's my banana?
We have hooked up a range of virtual humans by now, with speech recognition, dialogue understanding, procedural animation, so that they can walk, guide, gesture, and respond. The logical extension of Siri, Cortana, Alexa, and the likes, just that they can not only voice chat, but they can also show you what to do. We have just finished an exciting experiment focused on extracting recurring teaching gestures, the work of one of my PhD students, Xinyu Huang. You can see here one of the test tasks depicted, where our experiment participants had to instruct the trainee how to set up a cardboard fort in a specific given shape that only they could see inside of the smart glasses, inside of the HoloLens. And they were supposed to instruct in some modes even without voice, in other modes with hands and feet and voice together. Xinyu recorded with video, audio, a motion capture suit the instructor and extracted a rich set of recurring instructional gestures from the stream, leading to a new inventory of gestural animations for the holographic artificial intelligences. On the top, you can see a flip gesture, for example, that we extracted, visualized on one of the character models she created. It is evident what is next for us, and that we are going to merge the motion capture approach of the ghost tracking with the holographic AIs, so that we can open up avatar representations to classification, summarization, and adaptation. From where I stand, this is just the beginning, and we need more AI to make the metaverse reach its potential. But instead of making this case myself, here is what Mirage XR, Watson, and ChatGPT say. Give me 3 valid reasons why the metaverse needs more AI.
The metaverse needs more AI for 3 key reasons. 1. Enhanced user experience. AI can personalize interactions, recommend tailored experiences, and create realistic virtual environments, making the metaverse more immersive. 2. Intelligent content creation. AI can automate content generation, including 3D models and landscapes, enabling faster growth and a wider range of experiences. 3. Social interactions and collaboration. AI-powered assistants can facilitate connections, overcome language barriers, and support collaboration, fostering a sense of community within the metaverse.
Yeah, thank you. You can say what you want about the answer of ChatGPT. I fact-checked it and I'm quite happy with it, actually. I think these are really 3 valid reasons of why we need more AI on the metaverse to enhance the user experience, for intelligent content creation, and to provide us with social interaction and collaboration, and maybe sort of an embodied user interface that makes it easier for us to navigate and operate the metaverse. But to close with one more thing, here's one more example of what production tools already provide experimentally. Keijiro Takahashi's AI command implements natural language interaction for intelligent 3D content creation into the famous real-time 3D development environment Unity. The depicted AI command uses ChatGPT to generate C# code and evaluate it then using language interpreter APIs, saving time for the experienced and lowering entrance barriers for those still learning. No-code editors will follow post-haste in their footsteps, I'm sure. I'm not quite sure what the future will bring, but I find it terribly exciting. Thank you.